Yeah.
So, Shikhar, let's do one thing because this episode is going to be heard by a lot of people who are very new to Gen AI. Like, even if they've heard a lot about Gen AI, let's go back to the roots of, say, try and understand Gen AI from a very layman perspective. What is generative AI, right? I know it's a branch of AI, but like, where does it fall? Then what is LLM, GPT? Let's talk about that a bit. Let's start
Yeah.
with generative AI because I think that's the core of everything like LLM, even GPT, etc. Let's do that.
Yeah, I think so. So generally, there are two types of machine learning or AI models: discriminative models and generative models. So discriminative models are what we've been traditionally using for decades, which are still used in computer vision models and speech synthesis, speech classification, all these kind of models, where essentially what you're trying to do is you have a bunch of data and you're trying to distinguish the data from one label to the other. So if you have a picture of a cat or a dog, your job is to say whether this is a cat or a dog. Now you know that this image is either a cat or a dog. So you know your options already, and you're choosing between one of them. So from a technical perspective, this is what we call a decision boundary. So the model or the machine learning model is trying to find the decision boundary, and by that I mean, at what point do you say this is a cat or this is a dog? So its job is to find the point in the image space where an image from, let's say, a dog image becomes a cat image, and that's all it has to find. It has to find the distinguishing features between different labels, right?
Okay.
Um, a generative model is supposed to be much broader than that because it is supposed to figure out the general distribution of the data. And by that, what I
Okay.
mean is it's supposed to figure out what makes a cat image a cat image. So, how does a cat image not just differs from a dog, but in itself, what is a cat image? What is a dog image? Because its job is to be later on be able to generate a cat image or a dog image or something like that. So fundamentally, that is the difference in probability terms as well. You can frame it in a very similar way that given
Yeah.
these many labels, which label is this particular data? Whereas with the generative model, you're trying to figure out the general distribution, the general characteristic of the data that you're given. The data could be image, it could be speech, for example. So if it's speech, a generative model's job would be to figure out what patterns exist in speech, and then be able to, given some parameters, be able to generate new kind of data. So
Wow.
that's the essential difference between a discriminative and a generative model. And then your LLMs, your diffusion models, which are image generation models, text to image models, all of these are generative models which are being prompted by something. So when you're creating an image from a text, your prompt is a text, is like a caption or a description of the image. If you're talking with an LLM, then your prompt is your text, and that's your starting point to generate something. Um, and traditionally, these things. So when I was doing my masters and I was doing my internship, etc., what was state of art at the time for generative models was something called GANs, which is generative adversarial networks. I don't think they're used as much anymore. They've been completely overtaken by LLMs and diffusion models.
Okay.
But that was the state of the art back then. And
Hmm.
speech synthesis, like Siri or Google Voice was done using similar models as well. Um,
Okay.
and since then, what has happened is that the image generation side of it has been taken over completely uh, by diffusion models. So diffusion models
Okay.
are a mix. So at least the DALI model from OpenAI is a mix between GPT-3 and something called CLIP, which is another
Okay.
method of kind of combining text and image together.
Okay.
And so it's not just an LLM because there's also an image element to it. That's why we call it a diffusion model. But
Okay.
so that's one side of it. So the image side is completely been taken over by diffusion models today, and then the text side of it has been completely taken over by what we call LLMs today.
Hmm.
And LLMs themselves, again, I go back to when we were doing the kind of research. So essentially, these So text or music or video, these are what we call sequence data, because
Okay.
this is not just one data that you output. So when a model produces music or video, there are a lot of different outputs. And so let's
Okay.
say if it's creating a text, it's doing it at one word at a time. Let's say, right? So it's a
Yeah.
sequence of words. A text could be a sequence of words. Um, so for sequence generation, this kind of sequence generation, the state of the art at the time was what we called RNNs, recurrent neural networks. And there were a couple different types of RNNs, LSTMs and GRUs and blah, blah, blah. But
Yeah.
essentially, the main problem with them and why these, modern age LLMs came to be is because they were only capable of handling one token. And a token could be a word, it could be a small segment of audio, it could be one frame in a video. So it was only able to handle one token at a time. And
Okay.
more importantly, it only had the context window of one token before and after the token it was processing. So let's say that the job of a system is to translate a text from English to French, right? So then an LSTM in the old system would look at the first word and
Hmm.
then try to output a word given the next word of that word as well. So if I say a cat has four legs, it would look at a and then it would look at cat, right? When
Oh.
it went to the next word, it would go to cat and it would look at the previous word and the next word. But that's it. That was its context window. And
Okay.
so its context window was very small and it was only able to
Small.
output
Yeah.
one word at a time. So then the next revolution was Transformers from Google, which was about I
Yeah.
think 5 or 6 years ago. And Transformers, what they did was they used something called attention, but basically what they allowed you to do is you look at the text in its entirety, and
Wow.
you produce the output text in its entirety. So at any point you have the context of the entire text. So it essentially
Wow.
increased the context. Now, you might also encounter something called attention, which is very important in this context because attention allows the model to focus on the proper context when it's processing something. So if it's
Okay.
a long sentence, there might be different areas of focus in a sentence, right? And when you're
Yeah.
outputting that, attention allows you to focus on the part of the sentence that is relevant to what you are outputting right now.
Okay.
So that's the concept of attention. And then from Transformers, so I think the first big model to come out of Transformers was the BERT model from Google, which
Bird. Yeah.
is I think still used for its in its search engine for doing various things. But BERT
Right.
was not a generative model, so that's important to remember that BERT was not a generative model. It was
Okay.
mainly used for stuff like classification and sentiment analysis and stuff
Okay.
like that. So the first big generative models based out of Transformers was GPT by OpenAI.
Correct.
So the first version of GPT, and the idea of GPT was that so the first GPT that was came about was not really trained on supervised data. So we talked
Okay.
about unsupervised and supervised learning in the beginning.
Yes.
GPT, and that's why they were called generative pre-trained transformers
Transformer.
because they were pre-trained. By pre-trained, what they mean is that it's not trained on supervised data. So before training on supervised data, this is the model. So this is the model that's trained on just raw text, just lots and lots of terabytes of data,
Hmm.
but unsupervised, which is easy to get. I mean, it might be still very expensive to train, but the data itself
Hmm.
is easy to get because you're not labeling it. There's no manual effort involved. So
Oh.
that's what GPT was. It was just a general up until GPT 3. It was just a general pre-trained model that was trained in an unsupervised fashion to just
Right.
be like a text completion system.